Let's say we are predicting a daily productivity score of students y from two binary features. x1 coffee, +1 means had coffee, -1 means no coffee. x2 is sleep quality, +1 means slept well, -1 equal to slept poorly. And the data is x1, x2, y, and the data points that we have are 1, 1, 9, -1, 1, 3, 1, -1, 1, -1, -1, -5. We fit a linear model with an intercept. So y hat is equal to beta naught, which is the intercept, plus beta 1 x1 plus beta 2 x2. Now in matrix form, it still looks exactly the same. That is y hat is equal to x beta. And our solution also looks exactly the same. That is using the normal equation, beta hat is equal to x transpose x whole inverse multiplied by x transpose multiplied by y. Now let's build x and y. We include a column for the intercept by putting a leading 1 in every row, and then we put together the data of x1 and x2 from the given data points, and we also create the output vector y. Now next we compute x transpose x. Now think of x transpose x as all column dot products. So the columns that we have are, let's name them. So C0 is equal to the first column, 1, 1, 1, 1. C1 is the second column, 1, minus 1, 1, minus 1. C2 is the third column, 1, 1, minus 1, minus 1. Now C0 transpose multiplied by C0, that is the dot product of C0 with itself is 4, dot product of C1 with itself is 4, and dot product of C2 with itself is also 4. Next we'll calculate the dot product of the columns with each other. So dot product of C0 with C1 is 1, minus 1, plus 1, minus 1, which is 0. Dot product of C0 with C2 is also 0. Dot product of C1 with C2 is also 0. So the columns are mutually orthogonal. Because their dot products are 0, we'll say that they are mutually orthogonal. And we get a very pleasant simplification, that is x transpose x is equal to 400, 040, 004, or it is equal to 4 times the identity matrix 4i. So therefore x transpose x inverse will be 1 by 4 times I. Now let's compute x transpose y. Again, x transpose y will be the dot product of columns with y. So x transpose y will be, the first term in the product will be C0 transpose y, second term will be C1 transpose y, third term will be C2 transpose y. That is dot product of C0 with y, dot product of C1 with y, and dot product of C2 with y. So first let's calculate C0 transpose y, which is 9 plus 3 plus 1 minus 5, which is 8. Then that is the that is the intercept column. Next let's calculate for the coffee column. So C1 transpose multiplied by y, which is 1 times 9 plus minus 1 times 3 plus 1 times 1 plus minus 1 times minus 5, which is 9 minus 3 plus 1 plus 5, which is 12. Next, let's calculate for the sleep column. So C2 transpose y is 1 into 9 plus 1 into 3 plus minus 1 into 1 plus minus 1 into minus 5, which is 9 plus 3 minus 1 plus 5, which is 16. So therefore x transpose y is equal to 8, 12 and 16. Now finally we'll substitute everything in the normal equation. So beta hat is equal to x transpose x inverse x transpose y. So x transpose x inverse is 1 by 4 times identity. X transpose is 8, 12, x transpose y is 8, 12, 16. So therefore your final answer is 2, 3, 4, and therefore the fitted model is y hat is equal to 2 plus 3x1 plus 4x2.